How's it going, everyone? Welcome. Elvira Gonzalez here. Today, I want to finally wrap this project one in the war game, where the idea is to explore quickly all of the concepts that we have learned so far in React. Thanks to Josh Komewa, a software engineer that has previously worked at Khan Academy and then at Gatsby. So he actually create this particularly course. First is the joy of React, so as a way to get into the root of React, the fundamentals, and also is the ideas around React, so we don't miss this 60 years of software R&D, right? And the other is the CSS for JavaScript developers. To explore now is what are the fundamentals of CSS, the things that are relevant in 2025, and then is actually understanding is the different layout modes or all of these layout algorithms that CSS come with that allows to create, for example, this kind of interface. And as a front-end developers, so a lot of the time we need to actually know how to build this kind of layout and what a layout is and how those layouts are now presented in the browser. So what are the different type of layouts that we have that of course come with the CSS engine, and what are the spec, what the spec says, what is the fundamental of the spec, and also understanding the different type of layouts. So not only is the normal flow that it is made of the blog and inline element as well as the inline element, but also understanding is the position and the relative and absolute layout, right? As well as the float layout and flexbox and grid. But in today's video, because there's a lot, and I know that that's a lot, we're going to look at how can we replicate is this particularly layout here, okay, using React, all right? In again, as I mentioned before, finally is wrap this in today's video of the word game. This word game or this Wordly, right? It is a somewhat famous word made by the New York Post. I think it is the New York Times, where they have is this six grid, or they have this six guesses to figuring out a 5 character long. So here this is actually the layout. All right, so we have now 6 attempts to figuring out what is the guesses so far, right? So first we're starting is with the inputs and the outputs. So what are the things that we need to what are the things that we need, and then the output, a broad stroke, and then getting to the details, which is, well, let's go to now build the layout, integrate that layout to this, and then build the game logic as it is. So because I already built that, right, it turns out that this particular grid, it was a component that in this case it is a flexbox. If we inspect this a little bit, right, let's going to inspect this. So this is now a flexbox that say, hey, all of, so since this is a box, right, the diff guess result is a box, and this box will have now children elements, right? In this case, it's a span. So I want to all of these children's, instead of they're actually, if you don't set this, oh, the row, interesting. So I want to now is make all of these elements that live inside of the flex layout to behave not as a default behavior, which is like a row, all right, which is putting one element next to each other. So if we, for example, is remove this, what happened here is say, hey, each one of those elements that live inside of that, I'm going to put that next to each other, right? Which is similar at how now as you can see here, this is one, this is another, this is another, this is another. This is similar at how now the inline elements are works using is the normal layout. And I do find that's quite interesting to see that this is the normal behavior. It behaves like an inline element, tiki, 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 tiki. And but we don't want that behavior. We want is to say, hey, these elements, I want to take all the available horizontal space, and then the next element the same, and so on and so forth, right? So this is what by indicating the flex direction of these boxes to be a column, okay? So I want to all of this instead of one next to each other is behave like a column or as a block, all right, element. So now it actually render this. So this is one section, second, 3, 4, 5, 6, right? All of these elements were generated dynamically for us thanks to a utility function called range that is going to accept now is the start and the end and then the step to actually is return you now an array. Why do we need this? Because a lot of the time we want is to recreate these kind of sections. So these range utilities are very, very useful for us. If we're not, we will have is to replicate that. So for example, if you want to create now is a sequence of elements filled with 0, for example, you just say, hey, let's go to now define is the length first. In this case, similar to if you want to create this two-dimensional array, what I can say is this, right? So fill all of this with 0 initially. So fill all of the column with 0, all right? But in this case, let me pass is the length of 6 elements here, all right? And each one of those elements, I want you to fill them with now is a new collection, right? That inside of that, that of course, this will now represent is our the characters, right, or the word, the 5 character length. So you say, is this 5, right? As it is, and I want to now is fill each one of those elements with 1, or with 0, for example. So you can see here we have now our two-dimensional array with this. So this is how can we now create these collections of elements here, right? Pretty straightforward. So we create this two-dimensional matrix here, right? So, or we can use is the built-in methods provided by the language. Thanks JavaScript to do that, and all the effort of the TC39 group commit to actually make this thing possible. Because otherwise, well, and so in our case, we use now is this array. So the logic here is to say, since we want to now only render 6 element maximum or 6 collection, 6 rows in this case, right? Or 6 column, right? One next to each other. based on the flex direction. Okay, hey, this box I want to be a column, and then another one and another one, so on. So I want to render is 8 elements. I want to render is 6 rows here, in, I mean 6 column. My bad. So I want to render is 6 column made of these 5 character longs. So because anytime that I made an entry here, I want to now render these elements here at the first position, and then render is what's left, right? So in our case, this actually works as expected, right? I'm not sure what is the there you got it. We got the answer, right? We can say is this will be hello there, right? There's actually showing us is this key prop. We're gonna see that what it is, Wordle. So essentially what we're doing here is to say, hey, anytime that I receive that entry, I'm gonna pass these collections of all of these elements to the component, okay, to the guest component, and I'm going to render what I have in that collections, okay, and then what's left. And this is exactly what is this logic is doing. So anytime that we enter something here, okay, we are verifying is the characters. So we're checking, or I am checking. I'm checking is that I want to render is the content of that, the content, the words in my array, and also I want to render is the empty left space. Of course, once we hit the limit, we can still add in some elements as it is. So, but in our case, we actually add this, right? The logic was pretty straightforward. Actually, nothing too fancy or crazy. I think we're using is now cursor here. I really don't like to use cursor to do so, because it trigger is no, not now, it's no longer okay. But when I run this, yeah, it's no longer. But when I run the npm run def, is actually any change that I made, it triggers the browser. It's quite annoying, I must say. It's quite annoying. But in any case, so yeah, so we actually create this. Can you see what I'm doing? Yeah. I actually create this as it is. So instead of, so we're using is the ID to put it here. So the same for this. So if you use now the key, the same key, action here, if we're using is the same key for that, that is not something that React will be used to keep track of these elements, because at the end of the day, each one of those HTML tags are now seen by React as a JavaScript object that is made of the type, the ref, that is made of the type, the key, as well as its children, right, among other properties here. So in our case, if we want to generate unique random values in client side, we can use the crypto built-in methods and generate those random values for us. It's a UUID as it is, right? So here, by using this utility function client side, we can now generate those numbers as it is. Another way to uniquely generate this, to identify this, is to say, well, let me use is the ID, all right? But in this case, in order to make this unique ID, you can say is, hey, this will be now is uh, guess ID guess, and let's say this is guess column, right? Guess column. So the name of the component, and the other is here as well. So we can say is this. So this will be is now guess cell, right? To be more expected, and we can replicate this behavior here, or just simply generate is a random number to do this. All right. So I'll prefer to dedicate is this to crypto and random UUID, which is so far so good. And now, well, this indeed will generate is these unique values for all of these elements, and there will be no warning there. No, or it is. It say encounter two children with the same key. Guess cell. Oh, really? Guess cell. Guess cell. Oh, okay. Now, okay, makes sense. Makes sense. Okay. Key should be unique so that components maintain. But it's interesting. It say on guess cell. But it's telling me that those IDs that come from guess, uh, somewhat we have duplicate keys. That's quite interesting. Non-unique key may use children to be duplicated and omitted in future versions. Um, hmm. Oh, of course, of course, of course, of course, of course, and of course. Um, so I can use now is the ID there. You're right. You're right. You're damn right. You're damn right. I can use is the ID there. All right. I can use is just the ID here, and then down below I can use now a script to do so. Say, hey, well, let's go with the all trusty one, crypto random UUID. There you got it. So now there is no problem because all of these uh, collections of elements have now the unique ID. Okay, makes sense. Good, good. Um. Hmm. All right. Awesome. Now, dig it, dig it, dig it. Let me close all of this. This is actually not relevant. And here we go. All right. Okay. Okay. So next one. Brave browser. So what's next? Each cell should contain a letter if the guess instance has been giving a value. If not, the cell should be blank. Using num guess allows consonants when needed. No key warning in the console. Right. So far so good. Let me actually save that's the state of the app. Git status here. Git log. Search input. Yeah, I'm writing directly on main, search input, and then you got is the get add everything here, right? And get status first, get commit with a message, right? And that'll be is um, add guess layout, right? Layout and logic. So you can say push origin to main. You got it. Bam. All right. Good. Now, exercise 4. It is about to add the logic here. All right. Over the first 3 exercises, we have been setting up all the structure and scaffolding. It is time to do some game logic stuff. In this exercise, we'll add some CSS class to color the background of each cell based on the result of the correct answer. Okay, so if you give me now is this first word, what indicating is that if they're gray, this is not part of the word. If this is orange, this is part of the word but not in the position. And if it's green, it is part. It is in the right spot. It is part of the word and in the right spot. Oh, yeah. Inside of the game helper, you will find a helper function check guess. So before going and looking into that, right, as parameter, it takes single guess as well as correct answer. It returns an array that contains the status for each letter. So how can we describe is the data layer here? Okay, so for each one of those attempts. So we can say by describing as an object that it contains is the letter, all right, at that position. Let's start with the peer, okay. The other is the is same spot, right? As a boolean, you can say, hey, this will be now true. Let's say true, right? The other is same spot. Yes, it is. The other is letter is letter exist, right? You can say true as well. All right. To be a little bit more explicit, to say is letter in same spot. All right, is letter exists. And all of this, what we're doing is just to describe is what is the data that we want to represent here to actually show you this. So this is now, let's gonna call this as the object containing this guess, right? Which is, you can call this as the guess, all right? As the guess, as a word, all right? And this guess, because we are using is type here to define that data. So this guess, I'm gonna define here perhaps like a class. This guess will have now a constructor that you're going to receive this the letter or the word. All right. The word will be public. Say public word, right? And then I want to now define is this word to assign that whatever word we have. Okay. I'm not sure if this actually is allowed to do that. And the other, all right, constructor word, and the other is the different methods that this will have, or the different properties that this will have, which is in our case is, you know, this kind of data, right? So, but in any case, I want to simplify stuff here, to just using now an object to represent that single element. That is, we say letter, right? Letter. In each one of those letters, we're gonna have is a guess, right? So our guess, right? So what we can do here is defining now a function that is gonna calculate is guess somehow, or check guess. All right, we say, hey, check guess. I'm gonna call it check guess. All right, we're gonna receive that as an input. All right, it say, hey, this receiving is this letter, check guess. So what will be the input here? We want is to compare now two string here. That makes a lot of sense. You have string 1 and string 2, right? So I want to compare those strings if they have in the same spot and in the same position. So the output here, all right, if we give now an input here, let's say whale, so let's say whale, and the other is hello. You know, the guess word is, so this is the input, the first input, the guess, and this is the actual word, right? So if we want to do this, this is the input, so the output will be now is hey, a collection, that makes a collection here, a collection where each one of those letters will hold is that specific data here. So here we're clarifying is the input, okay, the input and the output for that, right? Tiki. I don't want to make this like so. In fact, I want to do this as it is, right? Input whale and hello. So the first letter will indicate now is this, that is this data, right? So letter is the first letter will be is W, right? So we want this to return is the data to print here on the UI. So letter here is letter in the same spot is another one. Let's say, of course, in this case is false. The other is the is letter exists in the word, okay. In this case we say false, right? Is letter exists, so false. And we're gonna do is the same for the other one, right? So for example, is age, is letter in the same spot. This is false. Is letter exists, you can say true, all right, and so on and so forth, right? So this is whale. So A is not on that, not in the letter, not in the excess. The other is whale. The L actually exists, all right. is letter in the same spot. We have to check that if it is. In this case, it is in the same spot. You say true, and then actually the letter exists as well. And then you have is the E as it is. You say, hey, it's not in the same spot, right? But it exists. So this is the output here, right? So how can we create this piece of logic here? Well, pretty straightforward. Now that we know what is the input and what is the output, okay, here we can say, let me grab this. So both of them must have, because both of so we have, because we set the constraint, both of them must have the same length. So it is much more straightforward to iterate through each one of those collections. That is great. That's great. So we say this. So this is the string one, and I want to is iterate to, or just simple say this. So for the letter in the string one. All right. So I do want is to not only get the value of the letter, the value, but also want to get the index. So I can, using is one single iteration, I can go over, I can traverse both collections. So I do think this is how you can actually do this. This is actually pseudocode. For in JavaScript here. Oh, but this is an object. This is not an object. Is an off array. Okay. JavaScript of iterator. Okay. Well. Let me put it is the off operator. The array, but not here on the for of the looping syntax. All right. And it's only gonna give me is the expected value. Can I have access to the index? Right. That's my question. Can I have access to the index? It's gonna give me only is the value there. Can you give me the index? Right? No. But this is, if this is an iterable, okay. But if I'm iterating over okay. So for iterables, but not like strings, all right. This actually doesn't give me is the index. Okay, no problem. So I can have access. So the iterator protocol, when iterated over a string, doesn't give me is the index, right? So if I make a quick, so hello, right? And then I say, hey, I want to now iterate through this. Say for the value of this iterable, right? And then I want to console log each one of them. So I want to iterate through this collection, right? So I get all of this, right? And my question is that since I'm iterating through a string value, can I do this? Do you support this? Okay, do you support this? But about the index, no, you don't support it. Okay, So this only give me is one value. So the iterator protocol behind the scenes is only giving to me one value. That's sad. That's sad. So for a string doesn't work that way. Well, in any case, no problem. Mm, 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 eh. um. Um. Yeah, that's sad. So I will go for a. I will go for a normal for loop. Say index. The index start with 0, right? Until I is less than string1 dot length. All right. So iterate while e is less than string. Iterate of that. Um, iterate while e is 0 is I is less than 0 is less than 3. So this is the stop condition. A is this 1 is because this is stopping condition. A is 1 is greater than 1 is greater than 1. 1 is greater than 5, no, continue. 2 is greater than 2, no, and so on and so forth. So is this one. Okay. Is this. Exactly, this is the expression 2, but the expression 2 is a condition to evaluate. Exactly. A is I is less than string, so is 1 is less than 2, no, continue. Is 2 less than 9, no, continue, and so on and so forth. Okay. Except this is the stop condition. Okay. And then, all right, let's get into this. Let's actually check both of these words. How so? Well, we can say string 1 at that position, and then string 2. So what I want to do is to check if both of them are now the same. All right. If they are the same type and the same value, well, it means that it is true, aka is letter is letter in same spot is the same, it exists. All right. So the other is that we need to check if this letter is part of the letter. So one way to do this is by saying, hey, let's going to iterate again through the collections. So for these small cases, looping again in the second string is not a big deal. But if we want to avoid that, what we can do is to iterate once through the entire collections, hold all of those values in a hash table, uh, so we can is compare that afterwards. Why that? You know. So if you have now these two objects, all right. If you have now these two objects, that have is the A, and in this case is hello, right? In the position, right? Say in the position 0, because we are programmers. Uh, so he, so you started to see is the pattern, right? Right, but let me actually make this much more straightforward. So if we have this, okay, right, that whole is now is the index, the value. So if we have this, and then we compare that with whale, for example, whale, for example, okay. If we have this hello, and then we compare that with whale, all right. What you can see here is both these data structures can give us is if a particular word, if a particular key actually is on the same spot and in the same position, right? So if we hold data for both of them, so if we iterate through all of these elements, um, and we hold both of that data, so we have now is mm-hmm, mm-hmm. Okay, okay, okay. No. Okay, okay. The problem here, I'm just wanting to go with the naive approach. I don't want to complicate my life. I prefer to go with a naive approach in this moment. So yes, this is it. So right now I'm using is this is letter in the same spot, um, like this is letter on the same spot, right? And the other is verify if that word, all right, actually if the word is present, um, hmm, if that word is now present in the word, all right, at that moment. So again, I'm doing is just for that. Um, and then I create now a new iteration to go with. In this case, is g minus a string 2 that length. Right, I want to now increment that. And what I'm doing here, oh my god, and what I'm doing here is this. Yes, and what I'm doing here is this. Um, mm, 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 mm. Mm. So what I'm doing here is this, right? It's iterating through that, right? And now I'm going to verify if that word, if that letter actually is part of the another word, and if it is, all right, good, good. Let me hold that data for you, right? Which is doing something like this, and say, hey, I want to say if the letter exists, right? So if the letter exists, which right now I don't know if that exists, I can say that I can set that to false, right? Iterate through that, all right? And as I iterate through that, through this, and as I get get that letter from the first word and compare that with each one of those letters from the second word, now I can verify if that letter exists, aka to do something like this. Hey, is the string one, or in this case, is that particular string, okay, is the same as the string 2, right? Okay. If it is, well, it means that letter exists, right? Is true. So we get out of this loop, all right? After we do the first iteration, right? And then it is time for us to build is the result data structure, aka this will be now our result. So let result. It'll be an empty array. So now, okay, after all of that, I do want is to do something like so result. So I want to push this element here that I want to define this as the data. All right. And this data will be is with the following shape, data as it is. All right. That is, hey, what will be the letter, the which is the string at that position, right? That we want to return, right? And also is letter in the same spot, and also this another value here is letter exist here, right? And then I want to now add the elements to the result, and once you go through each one of those letters in that word, all right, give it to me as a result, right? So now we can actually check this, okay, and by running this. Right, check guess. Okay. Check guess. Diggy. So the input here will be now is the whale. Right. You can say is check guess. And then here you have is the whale, which is the word we want to compare, and the guess word, the word to guess, right? And we're gonna get is this, where you say, hey, well, is the letter in the same spot? No, it doesn't exist. H is a letter in the same spot? It's a no, but the letter exists. So our logic here is wrong. A does not exist. L, L exists, is letter in the same spot, and its letter exists, true, and say, okay, our logic for is letter, so is letter in the same spot, that logic works. So is letter in the same spot, that logic works. All right. But what doesn't work is the is letter exists. All right. But of course, because here we want is to compare these two string, right? And give me is a Boolean value here, right? And that is as it is, right? So we're comparing is now the letter at that moment as we iterate through the letter of the first letter of the first word, and then we're gonna compare that with all the letters from the second word, and we're gonna do the same, and we're gonna do the same, and so on and so forth. So now this will work as expected, right? As you can see, it letter in the same spot, and no, but it letter exists. False. It's letter in same spot, but hey, string 1, if that letter and that position is the same as the string, so what we're doing is I want to iterate through all of these elements there. All right. Oh, exactly. I want to verify if that letter actually is the second one. No. Is the third one? No. Is the fourth one? No. Take it. So its letter exists. For example, if we compare here with whale and hello, like that, right? So we say, hey, W exists? No, because it goes through H, A, L, L. No, it's not. H, it is. It's a, it go for the first one and say, hey, this is a match. Its letter exists. Okay, its letter exists. Okay. Okay. Okay, I get it. No, I get it. I get it. Exactly. This is a condition. Hey, let's gonna put this as true. Right? And then I want to break here. I don't want to continue to evaluate this here. I want to break here. Exactly. So you can see now, H exists, it break the loop, right? A does not exist in the word hello. L does exist in the word, and it's only find the first character, right? And the other is this letter in the same spot here. It's not in the same spot, but it exists in the word. So I do find this is quite mind-bending and revealing. This is a non-optimal logic as it is, but at least the logic works. Okay, at least the logic works. status incorrect, incorrect, correct, misplaced. That actually shrink that a lot. And this is just now okay. So instead of returning is this, is say, what is the status here? Okay, to actually represent less data here. This was my naive approach. Okay, that actually worked as expected. That was my naive approach of how to compare this elements. There you got it. Look for the correct letters here. So iterate one. And it's a solve char. This content is a placeholder that is indicating we successfully deal with this character. It is correct or misplaced. If there is no guess, so return nothing. And then you have is this. You have the guess char and the answer char. You can also the result, right? And here you got the step one, the step two. So step one is look for correct letters. All right. And step two, look for misplaced letters. If it's not misplaced, it must be incorrect. Right? So in my solution here, so the naive solution of Euler naive solution. All right. Euler naive solution. Made in 30 minutes, something like that. I do think it is. Exactly. We have is in this, right? So first what we're doing is just iterating through the first leg. So iterating through since both answer, guess, and answer, which is the string 1, and the string 2, right, have the same length, right? Has the same length, right? I iterate. So this is, you can say is guess and answer words have the same length. Iterate and compare, right? Iterate and compare letters from answer. Iterate and compare letter from string 1 to string 2. In this, what we're doing is iterate. So compare is this. Compare current letter in string 1 with all of the letters in string 2, right? That's what we're doing. And if you find the first one, get out of here. This is the function, check guess, so you get the idea. Again, this is the naive approach. And yeah, that's it. Actually, they gave us, all right. I just want to do this exercise is to actually is a stretch is how you going to implement that, right? How you about so to how you are going to about to implement this. What are the trade-off and the approach here, right? And again, the approach here was what is the input, what is the output, and what is the intermediate step that we need to. And if we find in the process some other problems, well, what is the input, what is the output, right? Mm-hmm. So what do we want to do? Based on that, what is the input, what is the output? And there are three possible statuses: the correct, misplaced, and incorrect. In the example above, we have is the. So the thing here is that it's gonna give us is the proper CSS. That's what this function actually is doing, right? It's gonna give us is that. This status corresponds with CSS classes. The correct status has a correct class name, which will apply the green background when applied to a cell. Same thing for misplaced and incorrect. Your task is to use these functions to validate the user guess and apply the correct CSS classes. The final output for a given guess should look like this. Exactly. This is the accepting criteria. Import the check guess function from game helper and use it to validate each of the user guesses. When rendering the letter in the guess components, apply the letter status to the cell element. Empty guess slot should have the same markup as before. Exactly. So I don't have idea how to do that, but let's get into this, right? And that is, so we have to use now the guess to apply the proper CSS style. So the input is that we now is to receive is the word, the guess, and somehow now extend the functionality of guest here. Extend the functionality of that word. Extend the functionality of that word. Okay. So in other words, we're going to render is this guess word. This is gonna return us is the how do you call it? The check guess. All right. So you can say is the check guess. All right. So it's gonna return us is the letter and the status. Okay. And these computations here. Okay. So this computation will give us is this object. Okay. All right. Okay. So this will give us is now this computation here, aka if this give us this computation in the case of here, so now we have is I don't have here is the answer, but I can import the answer here. No, where did I get the answer here? Sample word here. Okay, so I can get that from the utils, all right, which is here from the util. Or now pass down data as a props, right? By saying is the answer to that component is the answer, all right? And now through these prop drillings receive that property here, right, as the answer, and then pass down that as the answer as it is, right? So this component now we're going to receive is the answer, right? And now that I have is the answer here, what I can do is to call that is the make guess, or guess what is the name of that? Is guess, no? Check guess with this. Oh, give me a second. miren que te ganaron de 9, man.
Ah, acá. Yo creo que es lo mejor que uno puede hacer, man. Definitivamente. As a man with too much of wealth, that's wise. Yeah. Voy a decir, ¿sabes?
And we are back. All right. So after we compute this, okay, we check guess. All right. This will return us is now an object. Okay. It will return us now as an object. Check guess. No, check guess doesn't have any of that. I don't know what check guess return us. Check guess return us is. Oh yes, it does. Oh, it thinks we are much more straightforward. If check guess actually return us this computation, we can now these collections. We can now map that. All right. And by mapping that, where we hold is the letter followed by the status, I do think that is what the check guess actually return us here. I don't know why this doesn't import. Why not? Why not? Why not? Why not? Why not? Okay. Exactly, because now this is a collection. Okay. We can have access is to the whether it's the letter, exactly, the letter and the status, that now on the cell here we can say, hey, I want to dynamically show is this, show the cell in the show the cell in the status here. Of course, this needs to be is inside of that. Right? And as the letter. So once we do this, all right, and if we run this, it says, hey, check guess, it doesn't come from there. Where does it come from? Game helpers. Okay. It comes from game helper. Game helper. You got it. And now we say, so we say is thin, we say hey thick, and it's now printing all of that. Okay, that's not what we want to. We need to actually is get rid of the get split. All right, computation, and only exactly get rid of this computation here, and only allowed to render is that. So when we render this and say hello, but it doesn't apply the proper style to this. I'm assuming is because the return object here, status here, guest character, and that and the position. So here we have this status followed by the letter here. Okay. It's not printing is the proper style here, but it say, hey, this is now undefined. We are properly receiving is the answer here. Let me actually check that in the component. No, we're not receiving is the, that's right, okay, we're not receiving is the answer. Let me go back here and pass down the answer, right? So now we should receive is the answer, right? Exactly. And then we say hello, or howdy, but it's not rendering is properly. Okay, it's not rendering that properly. We are passing down answer as expected. Okay, but not answer here. It's actually render this. It return us now is a collection here. It's going to compute on every render that guess, and the answer is going to iterate through that to get is the letter and the status. And here, if we inspect the sorry, my bad. If we say hey hello, even if we inspect the elements here, it say hey is undefined. Okay, but it say that this is undefined. The letter exists, but the property might not. Is status. We have the status. We have to print is a status here. And it say that this is undefined. So it's like no computing here. or is not returning that. So somehow React say, hey, this specific cell I am getting is this value of undefined, which to me is quite mind bending. Letter exists because otherwise it wouldn't print this, but the status does not. And I think this is most likely the logic inside of that. Check guess. Thanks to GitHub user Dialano for supplying a more accurate solving algorithm. Interesting. But it say no, it doesn't have the status there. That's it say that, hey, I don't recognize this identifier. That's what happened. I don't recognize this identifier. If you don't recognize that identifier, so I don't know what you are trying to do, right? Oh crap. Is okay, exactly. It's because that particular JavaScript file was called before this was even executed. And it was called with a different word, so in a different context. Oh, okay, but now it actually showed the proper letters here. Otherwise, howdy. Oh, we gotta guess. I don't know what the name of the word is, but you get the idea. You say hello there, world. Make a guess. That was very, 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 very interesting to explore about this. Very, very, very interesting to explore about this. Winning and losing. So we are so close. We only have one concern left, ending the game. If the user wins the games, a happy banner should be shown. Enter the guess and enter guess. Congratulations, you got it in number of attempts. Enter guess. Sorry, the correct answer is radio. So that'll be all for this video. Take care. Bye bye.